The credibility of an information systems (IS) audit depends fundamentally on the quality of evidence collected and the analytical techniques used to evaluate that evidence. CISA auditing standards require auditors to obtain sufficient, reliable, relevant, and appropriate audit evidence to support professional conclusions regarding the effectiveness of governance, risk management, and internal controls. Modern IS auditing increasingly combines traditional evidence collection techniques with advanced audit data analytics to provide continuous, objective, and risk-focused assurance. Audit evidence collection techniques. CISA Standard 1205. Evidence requires auditors to gather sufficient evidence to develop reasonable conclusions regarding the effectiveness of controls and procedures. Audit evidence consists not only of source documents and system records, but also of audit procedures performed, testing results, corroborating information, and supporting documentation used throughout the engagement. The sufficiency and integrity of evidence must be evaluated and reflected in the final audit report. Audit evidence serves as the factual basis for audit opinions and recommendations. High-quality evidence should possess several key characteristics. Sufficiency, adequate quantity to support conclusions. Appropriateness, relevance to audit objectives. Reliability, obtained from trustworthy and independent sources. Objectivity, free from management bias or manipulation. Timeliness, representative of the audit period under review. The reliability of evidence is influenced by the independence and qualifications of its provider. Information obtained directly from external organizations or independent sources generally carries greater evidential weight than internally generated records. Similarly, highly technical evidence requires competent personnel capable of explaining its origin, generation, and interpretation. IS auditors employ multiple evidence collection techniques to validate control effectiveness. Inquiry, interviews with management, system administrators, control owners, and users. Observation of operational activities and control execution. Inspection of policies, procedures, configurations, reports, logs, contracts, and documentation. Reperformance, whereby auditors independently execute control procedures to verify operating effectiveness. Confirmation, obtaining independent verification from external parties. Analytical review, comparing trends, ratios, or relationships to identify anomalies. Professional testing standards frequently require combinations of these techniques. Collaborative inquiry, observation, inspection, and reperformance are commonly used together, while substantive testing supports validation of control objectives through independent verification of transactions and processing accuracy. Evidence collected during IS audits commonly includes organizational charts, policies, standards, process documentation, correspondence, business records, system configurations, audit logs, incident reports, risk registers, third-party contracts, and system-generated reports. Interviews and direct observation complement documentary evidence by validating whether documented procedures actually operate in practice. Audit data analytics, including audit algorithms. Digital transformation has dramatically increased the volume and complexity of audit data. Consequently, auditors increasingly rely on audit data analytics (ADA) to evaluate large datasets efficiently and identify control weaknesses that would be difficult to detect through manual testing. Audit data analytics refers to the application of computational techniques to extract, analyze, correlate, and evaluate electronic audit evidence for the purpose of assessing control effectiveness and identifying anomalies. Rather than relying solely on manual sampling, ADA enables auditors to analyze entire populations of transactions or continuously monitor selected activities. One of the primary technologies supporting ADA is the use of computer-assisted audit techniques, CATs. CATs enable auditors to collect data from heterogeneous operating systems, databases, applications, and business processes while performing automated sampling, reconciliation, exception identification, and transaction analysis. They significantly improve audit efficiency and consistency, particularly within large enterprise environments. Common applications of audit data analytics include duplicate payment detection, segregation of duties, conflict analysis, privileged account monitoring, user access, anomaly detection, transaction sequence analysis, log correlation across multiple systems, continuous compliance monitoring, fraud pattern identification, exception reporting, and trend analysis. For example, correlating physical badge access logs with system authentication records can identify suspicious login activity that may indicate unauthorized access or credential sharing. Computational correlation enables auditors to detect patterns impossible to identify through manual inspection alone. An important extension of ADA is the use of audit algorithms, which are predefined logical procedures used to automate audit testing. These algorithms execute repetitive validation rules against transactional datasets to identify control exceptions, missing approvals, duplicate transactions, unauthorized changes, unusual access patterns, or violations of business rules. Examples include identifying users with excessive privileges, transactions exceeding authorization thresholds, or inactive accounts that remain enabled. Continuous auditing further enhances analytical capability by automatically collecting and evaluating audit data over extended periods rather than relying on periodic sampling. Embedded audit modules, such as Systems Control Audit Review File, SCARF, and Embedded Audit Modules, EM, integrate audit logic directly into production systems to perform continuous transaction selection, additional logging, and automated control verification. For CISA professionals, mastery of audit evidence collection techniques and audit data analytics provides the foundation for evidence-based assurance engagements. Combining professional judgment with advanced analytical technologies enables auditors to improve audit coverage, strengthen fraud detection, enhance control evaluation, and deliver more timely and reliable assurance over increasingly complex information systems.